All right, welcome back, everybody. I hope you had a very nice break. It's now time to turn to our first of 3 panel discussions for the day. The agenda is designed to start with a high-level commentary, like you just heard in the opening session, followed by foundational elements like research and quality criteria. In the afternoon, our focus will turn to STEAM in action, looking at creative collaborations in our third panel discussion, interactive exhibits, workshops, and tours around Qualcomm. And then we'll close in celebration with a reception from 5:30 to 7 p.m. And so Dr. M.A. Greenstein will lead our first panel discussion. The rest of the panelists, if you please come join us up on stage now. And I will turn it over to Dr. M.A. Greenstein. Let's give her a round of applause.
Welcome, everyone. Everyone who should be here is here. Every brain and mind and bod is here. What a thrilling, absolutely chilling moment for the neuroplastic brain. Axons, dendrites, neurons, glia, ion, channels. Have you done your prep for panels? Wait a second now, sparks begin to fly. Synapse, they are binding, they will bind. Wait for the spike. What a ripping moment that was just to see the action potential gain. What a thrilling, absolutely chilling moment for the neuroplastic brain. Welcome, good morning. My name we have music in the brain. I had to today. So I'm your moderator. I am very honored to be here after a long career, actually, in making and writing about arts and science out in the large world of international art and design. I've got an esteemed colleagues here that are going to unfold the story for you of how science is actually shedding light on the way in which art contributes to growing learning, memory, and specifically brain tissue. They're also here to share with you their research on the way arts and science, which have been together for a very, very long time in a common process to promote learning, discovery, and invention. I want to mention in the audience today, we've got Hal Walker and Betty Walker, who are really pioneers. Hal and Betty, would you please stand? They're my colleagues. They're NASA scientists. Betty Walker did the first science learning program with UCLA more than 20 years ago, yes? And they have a STEAM center in Inglewood, and this summer we're going to be promoting camps for the asteroid quest, because asteroids are falling. Now, I want to say that we've got goals today that we're going to be framing the information in terms of 3 big ideas, so please listen up. They're great take-homes for you for teaching and for administration and policy development, as well as product development. And we're also going to be dealing with some interactivity, and I'll invite you to address that in a second. But I first want to get out my slides and be able to share with you a perspective I think will help in understanding research. So may I have my slides, please? Oh, slides? So what I wanted to present to you today is a picture of how long this has been going on, this discussion has been going on. And I'd like you to imagine yourselves in Bologna. Who's been to Italy, by the way? Great, okay, so imagine yourself in Bologna, right? You're at the university, it's 1008, and this university just started. And this university quite famous for bringing arts and science together. You know, this is not the home of Leonardo da Vinci, okay? He was in a small village much later in 15th century, excuse me. But Bologna is the seat of this conversation. And we are bringing this conversation now centuries forward of how arts and science come together. Thank you. So, where do I point? Where do I point? Screen? Okay. We're already back. Go back. You just point to the screen. Okay. So let's get some pics up because we're visual people. Okay. So here. Okay. So this is our session. Yeah. In case you didn't know. Yep. And then let's forward. Great. And these are all the subject areas. They're just subject areas, and they also bring skill sets. Yeah? And we can have any acronym we want, but truth be told, these are the concerns of at the national level, the local level, and in the hearts and minds. Okay, so, and they're races. Remember, we came from the space race. If you're old enough to remember the space race, I'm a child of the space race. Right? And we've now been superseded by the connected, let's get connected race. And more to the point now, we're really at the brain race. John might be able to talk to you a little bit more about that, but the Brain Mapping Institute initiative here in the United States as well as in Europe. So much of our discussion today is going to be greatly informed by the fact that our government's getting $1 million to figure out how our brains work, and that's going to impact all the science, art, and education that we're concerned with. Oh, this keeps going on because I did it on automatic. So let me just go back. One of the things that I want to bring forth in our minds today is that we've got these initiatives, right, on research, but the truth is that you've got publications, exhibitions, and initiatives that have been contributing to this for a long time. Carol will talk about that, particularly the way artists and scientists have been contributing to exhibitions and publications. And I want to mention this year, Leonardo magazine, which has been doing this since for the last 40 years of creating intellectual property around arts and science collaborations. So what I'm trying to present to you today is just a historical perspective that this conversation has been going on for a very long time, and it is so exciting that you are here to continue that dialogue. At this moment, we're going to practice some research, right, to give you an idea of what my colleagues have been doing. And if you could bend down and pull the white envelope underneath your chair, pull it out. Thank you. And then don't open it yet. Don't open it yet. I know you want to, but don't open it yet. Anticipation. Anticipation. And once everybody has their envelope, if you would pull out the pencil and paper and the little silver thing that's in there. So there's a pencil and a little piece of paper and a little silver thing. Some of you might recognize, yes, okay? We don't know what this is, right? We don't know what this is. It may look familiar, but we don't know what it is yet until we test it and make inquiry. So if you could for a moment, with just the silver thing, if you could look at it now with research eyes and inspect it as if you've never seen it before. Inspect it as if you've never seen it before. Shape, size, texture, sound, scent, color. Inspect it. And now, if you will, please open it up slowly. Open it up slowly with your eyes closed. Yeah, with your eyes closed. Open it slowly. Be sure to feel every moment and inspect what this thing is. And once you've opened up, please smell it. What does it scent? What does it remind you of? And then you're welcome, if you dare, to put it in your mouth. And notice what it feels like to be in your mouth. eyes are closed, being able to use your spidey senses to get some insight into what this thing is. And now, as you're experiencing this, notice if any memory comes, any associations, places, people, how far back it might go, and any insights you have that you are willing now to write down on that paper with your pen. Just for a moment, write down what you've discovered from this inquiry into this thing you've just discovered. Just please take a moment to write down on pen, with the actual pencil, the golf pencil, on the paper. And just make any note on what you discovered through this inquiry of touching, inspecting, smelling, and then tasting this thing. And then please notice, as a scientist and as a designer, artist, what direction are you holding your paper to make your notes? Take note of that. What direction you're holding your paper. Is it portrait or is it landscape? The artists in this room will understand my question. So take note of that, and then please share with someone next to you that first fact, which direction you held your paper to write your note, and then please share some of your insights with the people next to you, behind you. Just take a moment to share insights as a collective community. What did you discover?
I didn't write it. As soon as I smelled it and saw it, I knew. Not my game. But I didn't have any experience with it. I didn't investigate it. I did the initial investigation. But that was what I should have written, huh? I can tell you I would have been landscape. There's not enough room to write a portrait.
Great insight. Thank you. One more. Yeah, please.
The three scientists here try to figure out why we had different portrait versus landscape.
Aha. Excellent. Great. One more, please.
The scientists, we just look at it, this is so wonderful. I know what it is, and I'm writing things like heaven. It makes sense.
There you go. Different ways of approaching a problem, right? And a question. Great. So we have now an experience that is the heart of what we're talking about. When art, science, design, engineering come together to discover something that we don't know. And how do we put our logic training, how do we put our habits and our past experiences aside so we can see in a fresh new way to what's before us. I'd like to turn now to Lauren, who's going to start to share, or Widney, who's going to start to share the research that she and John Iversen are conducting through UCSD, correct? Yeah, regarding music and the brain.
Good morning, my name is Lauren Widney, and I'm the Education and Community Program Manager for the San Diego Youth Symphony Conservatory. we run a music program down in Chula Vista called the Community Opus Project. About 4 years ago, we started this program in October of 2010 in partnership with the Chula Vista Elementary School District and their Dr. Escobedo. Thank you very much. And we started with only 75 students at 2 schools. And this was our way to help reintroduce music to an entire district because as youth symphony musicians and administrators, we know that there's something about music and the arts that can change a community, that can create space for different learning styles. And we base our program off of El Sistema. Raise of hands, who here has heard of El Sistema or Gustavo Dudamel? Pretty good. About 36 years ago, Jose Antonio Abreu started a program down in Venezuela called called El Sistema. And what it was a social change to create space for Venezuelan musicians to play music. Most of the conservatories there were for European musicians coming in Venezuela or the elite in Venezuela. He got students from the barrios, from any slum, any area that would never have the opportunity to have a music instrument, and gave them a chance to play. Now there's over 350,000 students who are able to receive music instruction in Venezuela. Each state has an orchestra, each city has an orchestra, and each little city and little pueblos, they all have an orchestra as well. And we took from this the philosophies of creating citizens through music. And as you can see here, this is our first year, and after about 4 months, we already started noticing differences in the student behavior, the attendance, and the parent involvement. So we started thinking about, what is this program doing for the community? And we're starting to think that it's proving music education is valuable to every child's development. We started tracking test scores, we started tracking the attendance, talking to parents, and looking for partners inside and outside of the community. We noticed something after our 2 years being in the program, that our students were performing at a higher rate than their peers that were not involved in music. This is one of the schools that Dr. John is going to talk about in a minute that we started focusing our research on. As you can see that the 4th grade Opus students are performing at a higher rate than the students that are not taking music. Well, what does that tell us? Something that they're doing is changing them. And we're thinking, well, is it their brain? Are we actually changing something inside of their brain? Are we just changing the environment? We wanted answers. We wanted to ask those big questions. And here they are. They all are receiving their medals for being proficient or advanced. Every single student at Lauterbach in our music program received medals for being proficient or advanced in English language arts and math. And so we started looking at our program. And you can see Dr. John on the right. We got this partnership going, and he says, there might be something about this whole music program in the brain. There's lots of research going on around it. And we said, well, how do we start to measure this? And I'm going to let Dr. John talk about that, but it's pretty exciting. They get to do a lot of different, battery tests and get their brain hooked up to machines. It's pretty exciting. And we can't ever do this all alone. We're so grateful for Mayor Cox and her office to make sure that we have opportunities and gives us a lot of support. And we know that all our music program is not able to do the research without partners such as, John Anderson over at UCSD Center for Human Development and CREATE and all of the different partners. And I know John is excited to talk about the brain research now, so I'm going to give a little segue into what we've been doing in Chula Vista and to what Dr. John's been doing.
Okay, I'm ready. So thanks, Lauren. I'm John Iversen from UCSD. It's a real pleasure to be here and an honor. I want to thank Kim and Ed for organizing this and inviting us. So I'll talk about the symphony study in a little bit, but first I just wanted to give a very short background about neuroscience and music, which is my particular interest and focus. As a neuroscientist, of course, we're interested in how the brain works. But one of my big questions, and a question of a growing number of neuroscientists, is, well, what does music do to the brain? And can we use music kind of as a tool to actually study the brain in general? And so one answer to that question, it's kind of obvious, is a lot. This is an example of some work by Charles Lim at Hopkins. It's showing a brain scan of someone improvising on a piano while in an MRI scanner, which measures changes in blood flow in the brain. The kind of hot colors are areas in the brain where activity is increased while improvising compared to just playing scales. The blue areas, interestingly, are areas where brain activity has gone down. So the main point here is just that music, listening or making music, is an activity that touches many different circuits and functions in the brain, as you can all easily imagine from your own experience: emotion, memory, self-regulation, attention, perception. So this is why it's become such a rich area for study in neuroscience. So we know that musicians' brains are different in some ways from non-musicians. Looking at adult musicians, I've found a number of changes in the brain. For example, it's been found that violinists, the part of the brain that controls the left hand, which is doing all the intricate fingering, is actually larger in violinists than non-violinists. Okay? And there have been a number of other kind of findings like that. If we're really honest, there's an important question is, well, is it like that because of the person playing violin, or is it that way because all the good violinists were born with greater left-hand control? So both are possible. So one thing that we're trying to do is to try to actually get at that question by studying longitudinally, studying kids as they learn to make music, to see if we can actually catch these changes in the act, so to speak, and then find more of a causal link. So there have been other findings in the behavioral literature about music and art in general effect on other academic disciplines like math and numeracy, reading, for example, reading fluency. You can imagine music has effects on the ear and how well the ear can perceive sound, which can have important effects on language. As Lauren mentioned, school attendance, a very kind of macro, but a very important thing. And then these kind of very important personal things like confidence and feelings of efficacy and ability to handle frustration. So all these things have been observed, but we'd really like to understand, what's going on in the brain that might underlie these things. The timing is great because at this point in neuroscience, we have a number of tools that enable us to study what's happening in the brain in various ways. And particularly the zeitgeist right now is perfect for doing this kind of study because of these imaging modalities and interest in development. These colorful pictures are showing kind of a colored view of a brain that's divided into different territories, and we can measure the growth of each of these different areas of cortex. We can also measure the growth of different subcortical regions. I'd love to talk about each one of these regions, but I don't have time now. The idea is that we can basically track how the brain is growing through time. And studies have started to show kind of developmental curves. We're all familiar with developmental curves for weight and height, okay? But we're starting to define the developmental curves for cortical area, or the area of different parts of cortex, or even connections between different parts of cortex. It's very essential aspects of what makes each of our brains different. So there have been some cross-sectional studies, which means look at a big population of people and define kind of on average what is the developmental trajectory. And we can see that cortical area increases and then slowly decreases. Cortical thickness decreases over time. This is from age 2 to 22. But you can see, while there's an average, there's a tremendous amount of variation around that average, okay? And what we'd really like to understand is for each of these dots, which is a single person at a single moment of time, how does that person's trajectory compare to the mean? How does it develop over time? So that's what we're doing now in the longitudinal study. We're actually taking these measurements year after year. So we can start to draw lines to see how each person changes. And the idea then is kind of this Symphony project, which is a collaboration. I couldn't certainly do this by myself. Some essential partners are at UCSD. Terry Jernigan runs this program called PLING, which is a longitudinal study that Symphony is built on. It was started when I was at the Neuroscience Institute and got a lot of support from them, and then of course, as Lauren mentioned, the Opus program. So it's kind of, my role has been to bring these partners together and kind of seize the opportunity to do this study. We have funding from a number of sources, which I'd like to thank. We're not quite at the point where the world is ready to fund a 5-year longitudinal study of music development and effect on brain, but it's sort of through piggybacking on these other studies we can make this happen. So the main goal is to understand how does music training affect children's brains and development of general cognitive skills like language and attention. And in particular, based on those trajectories, can we see if music training accelerates or changes developmental trajectories? The design is very simple. It's a 5-year study. We have a baseline, and then after the baseline, kids are studying music in the Opus program. We're comparing that to kids studying karate and kids studying just not music or not karate, sort of general control. So each year we have a battery of cognitive tests and then also these brain scans. And then we'll measure those year after year. And really to try to understand the connections between those. Right now, that's where we are. So we finished the baseline year, and we're in the midst of year 2. So maybe next year or the year after, I can actually answer the question that we've set out. Right now, what we've done are just some sort of, some basic looks. In the baseline case, how brain structure and performance on certain tasks might be linked. So this is performance on a rhythmic task. And we found a strong connection between the area of part of the brain, the basal ganglia, and the ability to listen to music and synchronize with it. Okay, it's a pretty low-level thing, but just the fact that we can find this link is encouraging. So what we'll do next is see, okay, in year 2, did the kids who got better at skill X, did their brains change in a certain way? And ultimately, it's really about building bridges. And just a final thought. We're studying these kids. We're also trying to teach them about the brain as a part of being in the study. And I think that's very important to make sure that the information goes both ways. And also trying to really include the schools as partners. Thanks.
So next we have Dennis Doyle, who will be presenting his research on CoTA.
I'm scrolling through some of these slides, and now we're ready. Great. Well, CoTA stands for Collaborations, Teachers, and Artists. And the organization has been in existence as a nonprofit since 1998. And we actually are now calling ourselves a profit organization. That's P-R-O-P-H-E-T. And we're very, very interested in the work that Dr. Iversen and Opus are doing. In fact, we've had quite a number of conversations about this work. We don't have the capacity to go into the brain and do this work. But instead, we look at people like Alex, the rapid mathematician, and we wonder, how can we train classroom teachers to be able to teach through the arts? And we have embraced a concept called arts integration. And our work is informed by the initial concept that comes out of the Kennedy Center. And this is their definition of arts integration. And it's a means by which students construct and demonstrate understanding through an art form. And they engage in this creative process while at the very same time addressing art standards and the academic subject content standards. So we have the opportunity to teach math through rap. We have the opportunity to teach science through theater. We have the opportunity to utilize many, many different art forms to teach other subject content areas. Now, we thought one interesting thing to do would be to submit a proposal to clone Alex, and that was rejected out of hand. So science didn't merge there with the prospect of the arts. But instead, we were able to get a U.S. Department of Education grant to study the process that we utilize in CoTA, Collaborations, Teachers, and Artists, to train classroom teachers on how to teach through the arts. A 3-year grant, and in addition to the workshops that we do with teachers, we also have teaching artists who work one-on-one with classroom teachers. And that's really critical, again, for a 3-year period working with schools. This work has been done in National City. I should add that Chula Vista also, Mayor Cox has really been very, very supportive of this work from back when she was on the school board in Chula Vista. We worked in Chula Vista, San Diego Unified, and National School District, but this particular work is focused on national. So in the course of training the teachers, UCSD is the evaluation partner here again, and they've been looking specifically at what's the impact on teachers. I mean, are teachers able to learn the art standards? And in fact, if they are learning the art standards, are they able to apply those art standards to the standards in science in a meaningful way? And are they able to apply those standards as well in math? And this is all work with elementary school teachers. 45 teachers, we found statistically significant growth in teachers' not only knowledge and their ability to apply those standards, but as well their feeling of confidence in being able to do that. So that's our first big idea, Dr. G, is teachers. And can we, in fact, demonstrate that a model of professional development is having an impact on transforming teachers as Alex himself was transformed? Well, that's nice. You can teach teachers, but then does it make a difference in the second translation, which is what happens when it's applied in their teaching to students? What changes do we see? And we found not only that students are more engaged in their schoolwork, and they're also very, very motivated, but as well, they seem to have greater ability to follow through. They have greater self-confidence. The engagement, the participation is really quite telling, and that again is at a statistically significant level. Looking at this small sample size of teachers and then students, a bit larger. I should add as well that we have a comparison group of students. So we have students whose teachers are going through the CoTA training, and then we have a group of students whose teachers are not going through the CoTA training. And this again is still preliminary, but in the first 2 years, we've got statistically significant higher scores in academics for the students whose teachers are going through the training at 2nd and 5th grade levels against the comparison group. Now our UCSD researchers are jumping up and down and saying, this is huge, you guys should be dancing on tables over this. And we're very delighted with this outcome. On the other hand, it's still preliminary. We're looking for dosage effect over the 3 years in much the same way that you are in your work. Where we're going next, I think, is really exciting. And we're working with Dr. James Catterall and as well Yvonne Shand O'Neill. Dr. Catterall is at the Kroc Center at UCLA. Those of you who are familiar with the research on creativity know he's been doing this for a long, long time. And he has an instrument now that can really get at what you're talking about in another way. So we're really sort of building, I think, a body of research here. And he has an instrument that's gone through validity and reliability studies and can look at a pre-assessment 3rd through 5th grade of students and a post to measure gains in creativity. More importantly, we think, is that his team then comes in and looks at what is it in the teaching that's specifically different? What is it in the learning that's specifically different? In order to pull that out and do some model building with respect to that. So there's a tremendous amount of research coming out, not only through Kroc, but also through Shanda O'Neill's work at the Kennedy Center. We're about to launch 3 new schools. We'll be expanding into Encinitas and moving as well into the East County in Cajon Valley, and doing some more work in San Diego Unified as well, doing this kind of research beginning in the fall. That's our third point. The fourth point, however, we're supposed to bring three big points to you. There's a fourth one that's pushing into this, and we said, no, only three. But the fourth one's coming at us, and that's parents. And so we've been doing a prototype now on training parents through hands-on active arts engagement to learn the Common Core state standards. And I see some folks here from the 9th District PTA who are very, very supportive of that effort, but that's coming up as well. So questions we'll be asking in the future: what impact does the training have on teacher creativity? And what impact does it have on student creativity? There's some research that Penn State University is doing on CoTA that's showing that at the very moments that teachers are seeing themselves as capable to teach differently through the arts, they're beginning to see their students differently. And they're looking at their assets, not at their deficits. And they're building active, creative teaching through that shift, which seems to be taking place simultaneously. In any event, I see the time is up. You'll have a chance to see coming up one of the terrific projects that came out of this. So you'll see some of the artifacts and some of the work that went into the design of aerodynamics and kite flying. And we'll also have folks staffing up the interactive exhibition table. Please come by, and we'd love to talk with you more about this. Thank you.
Thank you, Dennis. It's so exciting. Next up is Carol LaFayette, who is a principal investigator with SEED, and it's really terrific to actually have Carol here speak at the national level of the confluence of science, engineering, art, and design. Please.
It's been really interesting listening to this, and I'm going to talk about a network project that researches the researchers, and the people living this life and actively collaborating. I'll talk about 3 out of a baker's dozen areas for action to better support the intersections of sciences, engineering, arts, and design. And those 3 would be enabling, learning, and including. A little bit of background. SEED Network formed after a series of workshops in 2010 and 2011 that were co-sponsored by the NSF and the NEA. Back then, that was pretty amazing. Since then, our voices, along with many others, such as your own, have helped convince more federal agencies to develop interagency agreements to encourage partnering across disciplines and domains. The visuals here will show you some examples of STEAM within the SEED context. A major SEED initiative was the White Papers Project, chaired by Roger Molina at UT Dallas and of Leonardo ISAST, and co-chaired by Carol Strohacker, now at RISD. We worked with an international steering group. Coordinators and co-authors of the synthesis report were Amy Ione of Diatrope Institute and myself. The title of our report is Steps to an Ecology of Networked Knowledge and Innovation. It's an ecological metaphor mapping the social organization of those engaged in SEED practices, but it's also about the organization of emerging new knowledge structures. So the shift from an idea of information sharing as a tree of knowledge to a network of knowledge has profound implications. Through an open call, we asked the community what obstacles and opportunities they encountered and what related suggested actions they'd offer. We received 73 abstracts, 55 full white papers, 4 detailed meta-analyses, and 260 suggested actions. More than 150 individuals from 24 countries were involved, and I thank them all. From all these suggested actions, a qualitative analysis developed 13 clusters, or processes, to better support and enable transdisciplinary work. Many of them pertain to the interests of multiple stakeholders, requiring the interplay of public and private actors and organizations. In other words, it's complicated. The first area I'm going to talk about is enabling, involving sustaining balanced seed relationships. A recurring issue in many white papers is that of difficulties and obstacles faced in seed practice because of asymmetries caused by differing personal and institutional environments and value systems. In universities, the promotion and tenure process is problematic for those blending or crossing disciplines because of sociological resistance and how the work is measured. There's also difficulty in evaluating new scholarly practices. For example, how to understand the work of an art historian who collaborates with physicists when there are no physicists on the evaluation committee. Funding organizations are increasingly developing interdisciplinary programs, but there remain across-the-board problems due to differences in outcomes sought and the evaluations deployed. There are many artist-in-residence programs in science institutions, but almost no scientists in residence programs in arts, design, and humanities programs. Seed practice faces particularly challenging obstacles because of a large variety and depth of these asymmetries, and so this area is worthy of much more study and elaboration. Second, learning is the second cluster. It involves tapping into the passion and creativity of lifelong curiosity. An ecological model based on a systems approach is a valuable metaphor for envisioning new blended learning experiences. Pedagogical improvements include a move to decentralized, distributed, and integrated forms of learning. Student-centered models reify faculty as facilitators or co-creators of knowledge. There's a need to support real-time virtual connections between classrooms and private, corporate, and research groups that can help them become self-organizing and less hierarchical. Coalitions among private foundations, businesses, and learning institutions have recently blossomed. Challenge projects and service learning models have activated partnerships. Urban areas and those near research and business centers are in a better position to engage local and regional economies, while rural areas without access to institutions close by need collaborative networks for resource sharing. Homeschooling groups and community makerspaces would benefit from greater access to network facilities and resources that can support global outreach and collaboration. To assess the value of transdisciplinary learning, there's a need for more research that mines relevant frameworks. Theories about embodiment, forms of knowledge and learning related to hands-on and project-based experiences have been developed within philosophy, architecture, art, mathematics, and other fields. Studies in cognitive aspects of learning, theories of emergence, affordance, and literature about technology-based knowledge transfer hold the potential to contribute more understanding. Human factors such as attitude and self-identification, that is, owning one's life path, can provide a basis for understanding relationships between blended learning experiences, excitement, and engagement. We envision 21st century learning as a dynamic system by those of all ages who employ multimodal and perceptual approaches, alongside analytical, statistical, and computational ones. Such learners will creatively formulate the right critical questions to ask of new technology, and then will assign to computational systems the most critical problems to solve. Third, including involves spurring innovation through diversity. Including means consideration of underrepresented groups as collaborators, audience members, on the bases of culture, gender, identity, geography, age, and abilities. This is desirable for both societal, but also for pragmatic reasons, such as those motivated by current creativity and innovation theory. Some authors envision an inclusive, transdisciplinary research agenda based on global scale networks. Research in developing countries and embedded in local communities engage with people's real and immediate needs. Open source hardware, open data, and open access platforms and methods can help. Authors suggest supporting science and art ambassadors who use low-tech solutions and citizen science kits in order to share scientific protocols with communities around the world. Other authors note that academic programs in media literacy and media arts attract more members of underrepresented groups than others do. Therefore, supporting media-oriented programs may help counter persistent demographic imbalances among students and practitioners working with new technologies. Increasing interest in soft materials such as thread and yarn can improve STEM learning related to programming and math, especially for women's participation in STEM. Arts and crafts may also level the playing field for individuals from lower socioeconomic backgrounds. The internationalization of seed practice foregrounds cross-cultural issues. We need to celebrate partnerships among creative individuals and industries that result in broadly useful new technologies. So I've described 3 out of a baker's dozen for action to better support intersections of sciences, engineering, arts, and design. I would really like to thank you and for the organizers of STEAMConnect first conference. If you want to see the rest of the actions, go to seed.biz.tanu.edu. Thank you.
Thank you, Carol. Carol got cut off a little bit in our time. We are really going to let you have a break now and to network to figure out some of the ideas. I want to leave you with 3 takeaways that I think are relevant to what my colleagues have presented today. To remember, first of all, that we've got research that can contribute to looking at learning, behavior, and social and emotional intelligence in relationship to arts intersecting with education. Second is that it seems to be creativity is a really important buzzword that has now come back. It's critical. We talked about the makers, and now we're talking about research looking at creative skill sets. And third, as Carol pointed out, we really now here in this room have a chance to galvanize the spirit of partnership and networking. There is a force and movement at work. It is so exciting. I want to thank my colleagues, Kim and Ed, for your leadership in putting this conference together. Please continue now with the next sequence for networking.
All right, let's hear it one more time for all our panelists, please. So we are going to attempt the impossible. We're going to try to get a handout to you while simultaneously on a break. So here's what we're going to do. We're going to take a quick 10-minute in-chair stretch break. If you need to get up and use the restroom or whatever, please do what you need to do. But in 10 minutes, I'm going to daze and astound you with my math magical powers. So please don't leave your seats if you don't have to, but we're going to take a quick stretch break. Some handouts might be coming around, and we'll see you in 10 minutes.